G'day team, welcome back to another video. Today we're going to look at translating functions. So transforming functions, but we're going to look mainly at translation. So vertical translations, so moving it up or down, and then horizontal translations, moving left and right. So we're going to sort of define these in terms of general functions, and then I'll show you how it applies to a graph, and then how we can apply it to different equations, okay? So for y equals f of x, so f of x is our original function. If we add a on the outside of my function, that is our vertical translation, and it goes a units. So if a is positive, it goes up. So if it's plus 2, it goes up 2 units. But if it's minus 2, so a is negative, then it actually translates down, okay? So if it's plus, it goes up. If it's negative, it goes down. Now, if the thing I'm changing is inside my function with my x, that way I know it's a horizontal translation. So what we need to actually look at is whether it goes left or right. And one thing you'll find the further we go into transformations is the x coordinate, or the x change, does kind of the opposite to what we think. So if this is a negative in here, so x minus 2, it goes to the right 2 units. But if it's x plus 2, it actually goes left, okay? So if b is greater than 0, so this stays negative because there's already a negative here, then it moves right. But if b is less than 0, we get the double negative, which gives me a positive, we move left. Now, if I have both, so a horizontal translation and a vertical translation, we could represent that in like a vector sort of display. But we won't see that too often in these questions, okay? So let's just have a bit of a look at what this looks like graphically. So f of x is graphed below. So I've got my nice red function f of x. We want to graph on the same axis y equals f of x plus 3 and y equals f of x plus 1. Now, first we need to identify whether they're going to be horizontal or vertical translations. Remember, if it's outside of my function, it's vertical. If it's inside my function with the x, it's horizontal. So hopefully you can see this one's going to be vertical and this one's going to be horizontal. Okay. Now for part A, it's plus 3. So that means we're going up 3 units. And because we have a plus in here, I know it's actually moving to the left 1 unit. So it's actually going to the negative direction. All right, let's have a look at graphing A. And I'm gonna use pink for this one. Now, if I'm moving up vertically 3 units, that means every single point has moved up 3 units. So we're gonna assume that these are 1 grid unit apart, okay? And same with the X. So that means this point here, for example, will move 1, 2, 3 units up. So it's now there. Same with this point here. This point here goes 1, 2, 3 up to here. This minimum here goes 1, 2, 3. So it's there. And this point here also moves to there. And basically all we're doing is mapping the same function through those points. Okay, it's a bit trickier, but we can see that there. So everything's just been shifted up 3 units. So remember, when we're graphing, we always label our equation. Okay, plus 3, not plus 1, plus 3. All right, let's now have a look at part B. So that's a horizontal translation of 1 to the left. So that means, kind of like our first example where we moved everything up 3 units, we're just going to move everything across 1 unit. So this point here goes to there, to there, to there, to there, and to there. So you can see all my points have just shifted to the left 1 unit. And again, we're just going to map that same function along here. That is an ugly curve. It's a bit better. And just like that. And I'm going to label it down here, just a bit further out the way. f of x plus 1. All right, so you need to identify what translation we have and then apply that in the correct manner. Can get a little bit trickier when we're just looking at equations, okay? So find the equation of g of x, which is the result of the following translations. So we have f of x and we're told different translations. So part A, f of x equals 3x take 2, and it's translated 2 units downwards. Now downwards means vertical translation, so it's happening outside of my function. So what I like to do is write g of x in terms of f of x first. Now, because it's a vertical translation, I know it's outside my function and it's downwards, so it's minus 2. So all that I do is now write f of x itself, 3x take 2, and I've still got minus 2. So this becomes 3x minus 4. So that is my new function, g of x. Let's have a look at part B. It's a bit trickier. We've got 2 translations going on here. I've got 1 unit downwards and 3 units right. So again, in terms of f of x, now I've got a horizontal translation 3 units to the right. So because it's going right, I know there's a minus and it's 3. And then I've also got 1 unit downwards, so minus 1 on the outside. Now, thinking back to our composite function work, if I've replaced x with x minus 3 here, I need to replace this x with x minus 3 as well. So this now becomes minus 2x take 3 plus 1 minus 1. Now that plus 1 and minus 1 in the end will cancel out. So I'm left with negative 2x plus 6. And that is my new function, g of x. So a little bit trickier, but you've just got to keep in mind, horizontal translations go inside my function like this. Vertical translations go outside my function like these two. Keep that in mind and you'll be money. We'll catch you in the next video for our next transformation.